everybody, my name's Chris, and today I would like to try and show you some of the things I have learned about Arduino and its capabilities to water the plants. I'm not an electrical engineer, and I want to make it clear that I do not know everything about these devices, but I would like to show you some of the things that I have learned and found out about its capabilities. If you have questions, ask them in the comments, and I will try my best to give you answers or direct you to where you need to go. Today we are going to be using an Arduino Uno to water our plants when it detects that the moisture sensor in the soil is too low. I have put timestamps in the description if you want to skip to the coding portion or the portion that we go through the assembly, so you can find those in the description below. This project should be fairly straightforward and can be fun for everybody. This is kind of the goal of the project. I 3D printed this box and designed it. You can find it on Thingiverse to fit all of our parts. So we will get started. We're going to be using the Arduino Uno. This is an Elegoo Uno R3. It's a Chinese version of the Arduino Uno. It works very well. We will also be using the moisture sensor, the LM393 3 to 5 volt. Comes with its own little board and a couple jumper wires. We are going to be using this relay board. It's a 2 relay module. I've used it in other projects, so I will be using it again today. We have a 12 volt power supply and a 12 volt pump, a bunch of jumper wires, and a breadboard. All these items are listed in the description below, so feel free to check them out. And we are going to get started mapping out what our plans for this project are. For connecting our pins, I will be using several different colors here. Blue is going to be a control wire for our relay module. Pink, bubblegum pink, will be a control wire or the input wire for our moisture control board. Red is going to be a voltage supply, and black will be our common ground. So what we'll do is we'll get started with our moisture control board. We have 4 pins, and of those 4 pins we are going to be using 3 of them on the one side. So VCC is our supply voltage. We are going to connect that to our 5 volt. Our ground is going to be connected to our ground. So I'm just going to draw this black line down this way. Jump this line and come down. And our D0 is going to be connected to pin 8. So our pin 8 can come out this way, up, over, and down to D0. So those are the 3 connections of those 4 that we will be using for this project. The 2 on the opposite side of the board are going to go directly to our relay sensor, and it doesn't matter which way we're going to hook those up. As far as I know, I've hooked them up both ways and have had no difference. Alright, so moving on, we will be going to our relay board now. So our VCC, just like last time, will be going to our 5 volt. You'll notice a trend there. Jump that wire, we're up at our 5 volt. Now my relay module has 2 different relays on it. So it has the option for in 1 and in 2. Since we're going to be using just one of them, and it's going to be the number 1, I will not be using the in 2 pin. So the in 1 pin will be our pin that is connected to the Arduino at slot 13. So we jump those and connect them there. And our ground, again, goes up to the ground. And I'm going to run it off to the side here. Jump this one, run it this way, jump this one, and connect it in here with that ground. Okay, so that is our two kind of control portions of the board. Now, we also need to connect our 12 volt power supply to our 12 volt, oh, already messed up, to our 12 volt breadboard. And we also need to do our 5 volt to our 5 volt. Okay. Now we can also do, right away, we can connect our ground, which we have a ground right here on 14. Jump that, and come in here to ground. So now we have ground, 12 volt, and 5 volt. So on the other portion of our little diagram here, we still have our pump. Our pump is a 12 volt pump, which will need to be powered by our 12 volt breadboard connection. So what we will do is we are going to run it up the backside here and run it to our 12 volt connection. We're going to jump that and come here. Alrighty. And our pump is going to be controlled by our relay on the ground side. So we are going to use NO1. NO1 stands for normally open 1. So this circuit will be normally open when it is off, and when it's on, it's going to close that contact. Our common will go to our ground. So when it is open, there is no connection and our pump won't run. As soon as we signal it to be on, it is going to close our ground circuit and complete it, turning that on. So I'm going to come over here, jump both of these, come up, and connect to our ground. All right, so hopefully that makes sense. It is very important with Arduino to always use a common ground between your power supply, and if you're hooking up external powers, make sure to common them back to the Arduino. It can really mess up some of the things with Arduino if you don't. So, all right, from there we are going to get to putting some of this together on a breadboard. Now that we have our wiring diagram all drawn up, we can go ahead and start putting some of our pieces together. I would like to note for this model of the system, instead of using my pump, I will be using an LED in this scenario to show you kind of how it works just here on the bench. So yeah, I have a bunch of orange jumper wires. And orange will be 5 volt, gray will be ground, and then blue will be for my relay. And I didn't have pink, so I'm using purple for my moisture sensor board. So the first things I'm going to do is I'm going to do my Arduino to my relay board, or my breadboard, excuse me, so that everything is connected properly and I can just go to the breadboard directly. So we're going to start here with our 5 volt and just pin into the 5 volt and then pin into this bottom row with the long red line. Now the way this breadboard works is these 2 rows with the plus and minus here, the red we are going to use as power supply, and it is connected on the back side by a metal strip all the way down. The blue is connected to itself and not to the red all the way down, and we will be using that as a ground. So if I can pull my ground wire out here, we have our ground at pin 14 going up to our breadboard. So we got ground, which is right here. and we go to the blue line. Okay, now the way these columns work here in on the breadboard is they are tied together in this orientation vertically, not horizontally. So anything in this row will be tied together, but anything coming this way will not be. So with that being said, we will continue on. Moving on to our relay module, we are going to start with our ground, which goes up to our breadboard. So I've got gray, connects here, connects to the ground. Then we have our blue wire, which goes to pin 13. And that is from in 1, which is right next to it, and it goes to pin 13, which is coincidentally right next to the ground on the Arduino. Then we need power. So we go from VCC, which we are going to use an orange jumper wire, and we're going to jump up to our red band. Now we are going to do the moisture sensor, and it's very, very similar. So VCC is going to go up to our 5 volts. Go from here to 5 volts. Then our next one is ground, which goes up to our ground. And then we have our D0 pin, which goes to pin 8. So we got a purple jumper here. And this goes to pin 8. All right. So now the basics of our circuit are set up. We can take a look here for our pump, or in this case our LED. We need our positive going to the breadboard. In this case we are going to use the 5 volts. So we connect to our 5 volts, and then remember this row is all connected. So we just put it in line with that. Well, technically in this orientation it's a column. Okay. And then our ground side of our pump is going to be run through our relay. So I will pull this a little bit tighter here. We have our ground from the pump, which is going to be in this row right here, or column. And it's going to go to NO1, which is normally open 1. We tighten that down. Then we have on our diagram here, I'll move this over a bit, we go from COM1 to our ground on our breadboard. So we connect to COM1. And we go to ground on the breadboard. All right. And then last but not least, from our moisture control board, we go down to our moisture sensor, and it provides you, if you buy the sensor that's linked in the bottom, it provides you with a little jumper itself, and those just go right on here. All right, so our system is built, and now we can go ahead and look at putting some code on our Arduino Uno and see if we can get this started.
IDE
new page after you open it up. It has some stuff already in here for us, but we're going to continue just above it. If you need help downloading this, there are literally thousands of videos online, but just let me know down in the comments if you are having trouble with it. Go to Arduino's website and click on software, and it pretty much walks you through step by step what you need to do to download this onto your own computer. So yeah, the code we're going to be using today is a mix of if statements, and in a little bit more advanced code, it's going to be an if statement with a while loop. But if that's confusing, not a problem. I'm going to walk us through both versions right now. So the first thing we need to do is initialize all our variables. And that really, what it does is it tells the Arduino what is located in which pins. So we're going to initialize our relay in, so we say int space equals, or sorry, int space relay equals 13. And that tells Arduino that our relay is going to be equal to the 13th pin. Then what we must do is we must suppress it. To suppress it, it is the semicolon button. And that really just stops, in this language, which is similar to C++, it stops it from being put out repeatedly. And we're going to need that suppression after every line of code that we call our relay or we are trying to perform an action. So the next initial variable we are going to do is int sensor, which, if you remember, we have it on pin 8. And then I'm going to have another initial variable, and it's just going to be called val for value. All right, so that is it for the beginning. We can now move down to void setup. Now, the word void in this case is not as in delete or not correct. This is void as in space. So it says, put your setup code here to run once. So what we want to do is put in our relay and sensor, pin 13 and 8, and what they're going to do. We need to put in their modes. So we're going to call this PIN, capital MODE for pin mode. It turns orange, as you can see, because it is an internal function written for IDE. And then we're going to put a parentheses. We're going to say relay, comma, and then in all caps, output, because we want our relay to be an output. It's going to push voltage out and turn our relay on, or it's going to stop and turn our relay off. Don't forget your semicolon. We're going to do the same thing, got caps lock on, for our next relay, PIN, capital MODE, parentheses, sensor, comma, but this one's an input. We're getting a signal from the sensor and it's coming into Arduino. So we all caps, input. And then our semicolon. Now, for this portion, we are done. Now, make sure when you write this, it is inside this curly bracket. It has to be inside the 2. So now we move down to void loop. It says, put your main code here to run repeatedly. So in this section, everything you write is going to consistently run over and over and over again. So we're going to use things like delays, which is a time measurement that Arduino uses to exactly what it says, delay things. And in this version, we're going to use an if statement. So First of all, we're going to say val is equal to digital capital R on read, and then parentheses sensor, close the parentheses, and semicolon. So in this position, we are saying that val, or the value, is going to be the input from, or the reading of our sensor. Okay? We can go down a couple lines, and now we are going to do if, and then we are going to put our statement inside our parentheses. Now, an if statement is really exactly as it sounds. You are putting in a condition, and if it's true, it's going to do one thing. If it's not, it's going to do another. It's a lot like if a parent tells their child that they get ice cream if they clean their room. If the child cleans the room, then they get ice cream. If they don't, then they don't get ice cream. So in our case, we are going to check if val is equals. So we're going to say val equals, you need 2 there. And then we're going to say high in all caps. So we're saying if the value from val, from our digital read from our sensor, is high, then we're going to do something. Okay? So val equals high. We need our curly bracket. Come down 1 line. Now in this space, we are going to be defining what to do if it's true. And I don't know if anybody else picked this up, but when you take a look here, I will back up. When you put in this squiggly bracket and hit enter, if you watch right in here, it will give us another curly bracket to close the one we have. So we have to write our first true portion within there. So we're going to use a built-in function called digital, capital W, R-I-T-E, digital write, relay, comma, low. And this, don't forget your semicolon. This is really turning our relay on. So if the value is high, and if I'm learning this correctly, this high value is high resistance in our sensor. So if the resistance is high, then we are telling the relay to turn on. Now we are going to need to delay for any predetermined amount of time, however long you want your pump to run if it's on. We are going to say it's 5 seconds, but in Arduino IDE language, the delays or the time measurement is in milliseconds. So anything you have in seconds needs to be multiplied by 1,000. So we put in 5,000. Then we are going to use digital write again. Digital, capital W on write, parentheses, relay, comma, high, in all caps. We are turning that pump back off. Now, some of you may have caught it. I needed to come back up here and put my semicolon. It needs to be after each command. So this is what happens if that or if this is indeed true. Now, after our squiggly bracket, we can hit enter and we can write else, curly bracket. We can, and now we say we want to just delay for however long you want it to be delayed for. With an if statement, you're probably going to want to delay it for a day or 2 days. For this example, I am going to let it delay for 5 seconds again. Close that and semicolon. So at this point, we should be good to upload this and run it on our board. In order to do that, we can first verify it. We have to save it We can just save it just as that. It's going to compile our sketch and verify everything. It says done compiling. It tells us how much of the board storage space we used. But if you leave something off, this is what it looks like when you have an error. And it kind of tells you what to do. Expected, your semicolon before your squiggly bracket there, curly bracket. So once we have it confirmed, verified, we can just click upload. Before you do that, if you haven't yet, you might have to come to Tools and then confirm your port. I do not have my Arduino plugged in currently. 1 second. All right, so if we go to Tools, Port, I'm using COM4 for our Arduino Uno. You click Upload, it'll compile it, upload it, and now it's all done. All right, so that is the if statement. Our system is set up. We have written our code for our if statement. This light will indicate our pump. As soon as we turn this on, if it does not indicate that it has enough water, it is going to run our pump for whatever we said the delay was. In this case, that's 5 seconds. So the pump will run for 5 seconds and then shut off. Then it will check to see if there's enough water on the pump or on the sensor again. If it is, it won't pump. If it's not, it's going to pump for 5 seconds and then shut off. So we'll plug our device in. It initializes. It notices that there's no water on the sensor. The resistance is high. So it ran our pump for 5 seconds. Now it's shut off. It checked again after 5 seconds. It says, hey, the value is still high. It runs for 5 seconds. So once it turns back on, now it's pumping. Let's imitate it being in water. It's going to continuously pump because we said it wanted to be for 5 seconds. Now we can see that the pump is not coming back on because the value is low. The resistance in between the two contacts is low. That is being told to the Arduino. It's saying, hey, the statement is not true. The value is not high, so we just need to delay. You take that out. After that delay period, it says we need water. It's going to run for a predetermined amount of time. The problem with this system is if you pump and the planter fills up with water, but the delay has not run out, it is still going to keep pumping water. So once the pump turns on, even if the sensor recognizes that it's wet, like now, the pump still runs. And that could be a problem if you have your delay set for too long or whatnot. But once the sensor is in there and it's wet, the Arduino realizes that and it doesn't turn your pump back on. If we want to do an if with our while loop, we will need to write this a little bit different. The advantage of having the if and the while loop is the pump will continuously run until the sensor recognizes that there is enough moisture in the soil. With just an if statement, it's just going to run for a predetermined amount of time. That's perfectly fine as long as you know how long it takes for your plants to dry out. If you don't, then an if and a while loop is probably what you're going to want to take advantage of. So it starts pretty much all the same. We have our initialize, the relay is in pin 13, sensors 8, and val. We have our relay is an output for our pin mode for our sensor is an input, and then we are saying val is equal to digital read sensor. Now, it starts off identical if parentheses, val is equal to high in all caps. We have our curly bracket, hit enter. Now we're going to write our while loop. So if the resistance in our sensor is high, we say while, and we write the same thing, parentheses, val is equal to high, curly bracket. So if it's high, then we're going to do this. Now, while it is still high, we are going to want our pump to pump. So we write digital, capital W, write, if I spelled digital correctly, parentheses, relay, comma, low, parentheses, semicolon. So now our pump is on while our value, our sensor, is high. We are going to delay. Now, this portion of the code is a little bit tricky. What we want to do is we want to delay a very, very short amount of time so that our pump turns off as soon as it gets enough water. So we can do 1/10 of a second at just 100. So every 10th of a second, it is going to stop if it reads that the value is correct again. But in order for it to check, we must reconfirm that val is equal to digital read of our sensor. Now, if you don't put this in here, your pump will just constantly run, because when it checked this, while val is equal to high, it checked it and said, yes, it is. And it never bumped out of this loop in order to re-evaluate what val is. So by writing it again down in here, we are saying, hey, you've put water on it, now check to see what it is. All right. Now, outside of our while loop, we are going to say digital write relay high. And this will shut our relay back off. So it's saying while this value is high, pump the water. As soon as you start pumping, read it again. If it's still too dry, it'll just continue pumping. But as soon as it notices that it's at the proper moisture, it is going to bump out and say, nope, this value is now low, and it's going to turn our pump off. Okay, so this is all one piece. Now we need to write our else. Outside of the if, you don't actually have to write else if you only have one other piece of information for it to follow. If you have several different steps you want it to check out, then you have to write else or else if. But in this case, we are just going to say else delay 5 seconds. Remember, it's in milliseconds, so we must times it by 1,000, our semicolon, and then we can check our sketch. Alrighty, it likes it, it's done compiling, and we can upload. Perfect. Alrighty, let's take a look at what it's actually doing for us. Okay, so we have written our code, we have uploaded it to the Uno, and now it is time to test to see if our system works. Remember, I am not using an actual pump. This green LED will turn on when the pump is running, and it'll turn off when the pump shuts off. So we can go here. So starting out, the LED is on, and that means the pump would continuously be running at this moment. The resistance in between here is high. So as we saw in our code, if this value is high, then our pump will be on. Now this is the while loop code. So once I dunk this, it is going to shut the light off immediately. So now the sensor has created a contact, the resistance is low, and it has turned the pump off. When I take this back out, it is going to wait a predetermined amount of time, which we wrote in our delay, and now it's turning the pump back on, saying, hey, there isn't enough water in between the sensor, and it is going to continuously try and run that pump. As soon as we want it back off, our sensor has enough water and the pump turns off. So what we have in this box is everything that you see here, plus a couple extra pieces. I couldn't fit a breadboard down in there, obviously, so I have made my own little PCB, and then just connected the ones I needed, and that's down, way down in the bottom, if you can see it there. I did not go with just jumper wires for my sensor. I went with an output jack, which is very simple. It just has 2 wires on it. Connect those there, and then the plug style, the male end goes into the other side with 2 wires, and it connects to your sensor. 12 volt input in the middle, and then our 12 volt output for our pump on the opposite side. I put a little on-off button in here, just in case if you were changing out the water or whatnot and you didn't want the pump to continuously run, you can shut it off. That's just a little open or closed switch. This box is like this when it's empty. This is a second revision, it's a little bit longer, but the first revision, if I actually show you guys here, the first revision works almost identically. This actually just slides down into these little notches on the end. Your relay slides down vertically down here, just as you can see there. And then your moisture control board slides down in here. And I made this one extra long because I figured me and other people in the future would probably want to put a couple boards in here and have different moisture sensors going out to different places, different plants. I designed this with the 2 relay module in mind because I also thought eventually I would want to hook this up to an artificial light. I live in northern Michigan and we don't get a lot of sun, so that will probably be my substitute for that. But if you check Thingiverse out, you can download this and 3D print it yourself. Let me know in the comments if you have any problems or questions with that. So I believe that is all. I will show you a finished result of my pump working, and yeah, thanks for watching. Let me know if you have any questions, and I hope you have a wonderful day. Alright, so here is my strawberry plants. It has already been watered, but what I will do is I will pull this sensor out. This is running the while loop. So when the sensor is out, kicks it on and fills it up with water. Yeah, so that is my system. If you have any questions, again, let me know, and good luck on your building.